Assalamualaikum and very good afternoon to all of you. Welcome back to our class BAA 2213 Reinforced Concrete Design 1. Today, in the first day of week number 2, we will go through the topic 2, which is analysis of sections, which we will focus on the rectangular beam sections. Okay, here is the learning outcomes for these topics, where by the end of the topics, students should be able to understand the relationship between the stress and strain, and then you must be able to understand the failure criteria, which is the under reinforced, balanced, or over reinforced design, and you must understand the application of stress block in the design of beam. And you must be able to apply the stress block analysis to determine the ultimate moment resistance of RC beams. Okay, this means that you must be able to determine the moment capacity or the maximum bending moment that can be resisted by the RC beam. Okay, here we go. We take a look on the stress-strain relationship, where when load is applied to a structure, the deformation occurred on the element will produce the stress and strain. Since RC is a combination of concrete and steel, therefore the stress-strain relationship of both materials need to be understood. And here is the stress-strain curve for concrete, where the maximum stress is taken as 0.85 FCK divided by gamma C. Gamma C is the partial factors. Okay, this one in topic number 1. Okay, in topic number 1, if we can still recall, this is the partial factors of safety for concrete. The value is equal to 1.5 for ultimate limit state, and this is at the yield state. Okay, the value is equal to 0.5 FCK. FCK, anybody still can remember the FCK? What is FCK? Okay, FCK is the compressive strength of a cylinder sample after 28 days. Okay, let's say C30/37. So the value of FCK is equal to 30 Newton per millimeter square. Okay, and this is the value of strain for concrete at yield, and this one is at the ultimate state. And this is the strength classes for concrete. This table you can find in Eurocode 2. Okay, in page 249 in Eurocode 2. Okay, and this is the strength of concrete. This is let's say this is C20/25, where the FCK is equal to 20 and the FC cube, okay, FCU equal to 25, and this is for C30/37, and this one is C40/50, and this is other characteristic for the concrete. Okay, and this one is for the steel. Okay, at yield state, the design strength is taken as FYK divided by gamma S. Gamma S is the partial factor of safety for steel, where the value is equal to 1.15, and the FYK is 500 Newton per millimeter square. Okay, and as being highlighted by chapter 1, the beam behavior in bending is like this one. Okay, this is for simply supported beam. Simply supported beam is a beam, single span beam, which is supported at both ends. Okay, single span beam, which is supported at both ends. Okay, here when we expose the beam on the loading to a load, and then the crack, okay, the compression will occur at the top part of the beam, and the tension will occur at the bottom part of the beam. That's why we provide the steel reinforcement here at bottom part of the beam in order to cater for tensile stress. And for simply a continuous beam, okay, this one is continuous beam because the span is more than one and is being supported at all end of the span. Okay, let's say this is span. Okay, this is span number 1. This is span number 2, and this one is span number 3. Okay, so we have 3 span of beam, and the number of support is equal to 4. 1, 2, 3, and 4. Okay, for this kind of beam, when we apply a loading, this is the deflection, the shape of deflection at the middle span. This is the middle span. The middle span, the tension will occur at the bottom part of the beam, while the compression will occur at the top part of the beam. Okay, it applies to all middle span. However, at the support, okay, near the support, different situations occur where the tension occurred at the top part of the beam and the compression occurred at the bottom part of the beam. So that's why at the top part here and here, we provide the steel to cater for tension, for tensional stress. Okay, any questions for this level? I hope you can understand and you can imagine where to put the steel reinforcement, either at the top or at the bottom. Okay, and the this one, okay, we call as flexural reinforcement. Also this one, okay, inside the beam is located horizontally. Okay, horizontally, flexural reinforcement, or the main reinforcement, or the bending reinforcement. Okay, this is okay the similar theme, similar thing inside the RC beam. Okay, the failure modes or failure criteria, they're divided into 3, which is first is the underbalance, second one is balance, and the third one is over reinforced. For the case of under reinforced, area of steel reinforcement is very small as compared to the area of steel. Okay, let's say this one. Okay, for the middle span, okay, this is the sections, and we provide the steel reinforcement at bottom part. Okay, we only can see two number of steel bar. Okay, within the tension region. Okay, and the steel will reach its yield strength earlier than the concrete because the amount is not enough. So that's why it will yield faster than the concrete. And if the balance situations, this is number 2, steel will reach its yield strength at the same time as the concrete. And this one is the ideal design. So we can see here at the tension part, okay, which is the bottom part at the tension region, we have 1, 2, and 3. Okay, 3 number of steel bar. So this one is will cause that this one will cause the steel yield at the same time as the concrete. Okay, the number, this is just an example. Okay, this is just example, not necessarily by 3, maybe 2, 4, depend on the depend on the value of bending moment, depend on the strength of concrete, depend on the loading, size of section, and so on. Okay, and over reinforced is the situation where the concrete will reach its maximum strength earlier than the steel. So failure occurs caused by early failure of concrete in compression. Okay, means concrete will undergo compressions faster. Okay, it will fail in compressions. Failure happens without warning. Okay, this is very, very dangerous. Let's say you see here, the crack occur at the top part. Okay, due to the over compressions. And we see here we have 6 number of steel. Means the steel still in elastic state, but this one already failed because it reached the maximum strength. Okay, and this is the stress strain of a sections. Okay, let's say we have a simply supported beam. Okay, supported by here. Okay, and A and B. Okay, we impose a load, okay, on the beam, and then we can see here, this is one. Okay, please take a look on this very, very important feature of the stress blocks. Okay, these three we name it as the stress blocks. Okay, where the epsilon cc is the maximum stress of concrete in compressions, epsilon st is the maximum stress of steel in tensions. Okay, and then the x is the depth of compression face to neutral axis. Okay, and this is the section of the beam. They say this is okay. We cut here. Okay, section A, and here is the section AA, and then we have the neutral axis here. Here is the neutral axis. So here at the middle span, the compressions will occur at the top part of the beam, while the compression tension will occur at the bottom part of the beam. So we must provide the steel reinforcement at bottom part of the beam. Okay, we have a triangular, rectangular, parabolic, and rectangular shape of stress blocks. Okay, and the value here from the top to the neutral axis is x. And the triangular block is for serviceability limit state. The parabolic rectangular stress block is for the ultimate limit state, and the rectangular stress block is a simplified alternative to the rectangular parabolic distributions. So the rectangular and the rectangular parabolic is a similar one, where this both for ultimate limit state, and this one is simplified. We simplified the shape. So the S here is equal to 0.8x. Okay, to ease our calculation later. Okay, any question up to this level? Okay, here is the type of beams. We have a rectangular shape of beam. Okay, this is the cross section of rectangular type of beam. Either singly reinforced, let's say this one, singly reinforced, or doubly reinforced. Doubly reinforced is okay when we also consider the reinforcement at the top part. And then the flange. Okay, this is the situation of flange beam with flange, where we consider the concrete inside the slab. Okay, originally this is from our slab, so we consider the contribution of the concrete and the steel reinforcement there. This is, we name it as the flange. Okay, divided also by two different category: neutral axis in the flange. Let's say this one, this is the neutral axis here, or the neutral axis below the flange, this one. It also have a singly and doubly reinforced. It's okay. So for this week, we only focus to the rectangular shape of the building, and next week we will go through to the flange shape of the beam. Okay, and be careful of this one. This is the design of rectangular sections, where these two types of rectangular sections, first of all, we have the singly reinforced, which consists only tension reinforcement. We mark as AS. Okay, look, please take a look carefully and how we write down A, capital letter of A, and subscript of S. S tu kecil je kat bawah. Okay, This one, this is the S, okay? After alpha S, this one. Okay, let's say this is the I'm talking about the middle span, okay? Middle span where the tensions occurred at bottom and compression occurred at top part of the section. Okay, this is the AS, okay? And the top reinforcement are hanger bars, which is used to produce a cage-like arrangement. We also provide bar here. This is only 2 bars. We call it as a hanger bar because later on we will complete this beam with the link or shear reinforcement. Okay, a hoop like this one. So okay, end up with this one. So that's why we provide 2 bars here as hanger. Okay. However, for doubly reinforced, it consists of both tensions, which is AS, and compression reinforcement, AS prime. Okay. This is the AS. For tension is AS. For compression is AS prime. Okay. Let's say this one is at the bottom. At the bottom part, we have AS. Okay. Area of steel provided for tension, and AS prime here at the top part we provide for compression, because for these sections the concrete itself cannot the concrete are not strong enough to cater for the compressions. That's why we provide the steel reinforcement here to help the concrete to cater for compressions. Okay, boleh faham tak setakat ni? Kenapa kita perlukan AS prime di sini adalah kerana concrete, okay, based on our calculations, maybe the bending moment is too high, so the concrete here cannot cater for compressions. It will fail if it works alone. So we provide the steel to help the concrete there. Okay, this is what I said before about the cage-like arrangement. So this is the, maybe this one is AS prime, okay, and this one is the AS, okay, and this is one is the link. We call it as link or shear reinforcement. Okay. Okay. Any question up to this level?
Question kena ikut simbol ni AS prime AS.
Yes, be careful. Be careful when you write down your equations. AS prime for the top for this one, okay. This is at the middle, okay. At the middle, AS prime is located at the top and AS is located at the bottom. What was we designed for the, okay, good question, thank you. Okay, for this one, okay, the AS, okay, this one is AS, okay, at the middle span is AS at the bottom, and this one maybe we provide hanger, okay, both, okay, here hanger or AS prime, but at the support, okay, near the support, okay, both, okay, interior or exterior support here and here, we provide this one. AS is here. AS is at the top part of the beam because of this one. Okay, we want to cater the tension here. Okay, that's why AS is provided at top part. Okay, and maybe we need the AS prime at the bottom part. Okay, be careful. Okay, at the middle and at the support, that's the difference. Dia terbalik tu, okay, you kena berhati-hati kat situ. Kadang-kadang kita suruh you design dekat support tapi you buat AS ni dekat bawah, so tak betul lah. Okay. Okay, thank you so much. I will stop my recording here and then we will do another record. Okay, we continue our class. Okay, for this one is, please give full attention because this is a very important part. Okay, balance. Okay, in order to get balance situations, simultaneous concrete and steel yielding must occur. So based on this stress block, okay, okay, this one is from the compressions, and this is for the tension. Okay, and the D is here. D is here. Okay, from the top part of the this one. Okay, from the top part of the from the top surface of the beam up to here. Okay, this is the position of steel reinforcement. Okay, this is let's say this is the steel reinforcement. Let's say we have two. Okay, this is the position of steel reinforcement. To the center of the steel reinforcement, this is the D. Okay, nanti kita akan tengok macam mana calculation of D tu. Okay, dalam kita punya latihan dan tutorial kita akan tengok macam mana nak tentukan D. Okay, so this is the X. So this one is D minus X. So X over D, can you really imagine? X is here, X over D. Okay, also D is here. Senang cerita sini lah. D is here. This is the D. Okay, this is D. So this is 0.035. Okay, sini. Sambung sini 0.0035. Okay, so X over D, this one is here. The ratio of X over D is equal to 0.0035 divided by 0.0035 here plus the 0.002175, or we can get it as 0.617, and then hence the D we bring here is become X equal to 0.167 D, and Eurocode 2 rounds it down to 0.45 to be on the safe side. Okay, this is the limit of X by Eurocode 2. Okay, and this is for singly reinforced. Today I plan we take a look only for the singly reinforced, or maybe we can take a look on the doubly reinforced if you have time. So for the singly reinforced, okay, singly reinforced is this one is for AS is the area of steel provided. Okay, it will contribute to the to cater for tension. Okay, if you still can remember, the very basic is the pressure. Okay, pressure or the stress is equal to F divided by A. Okay, FST is the total force to be catered by the steel. Okay, force by the steel, and this one is force by the concrete. Okay, to make it equilibrium, okay, total force must be taken as 0. Okay, and this is the area of concrete. This one is area, and we have the stress. This one, if you still can remember, okay, from our stress-strain relationships I show you before, this is 0.85 FCK over gamma C. Okay, this is for concrete. So this one, okay, since the value of gamma C is equal to 1.5, so 0.85 divided by 1.5 equal to 0.567 FCK. This is the stress, okay, the stress for the concrete, and then the area is equal to this one. Area is equal to here 0.8x multiplied by B. This is the B. B here. B is the width of the beam. Okay, this is the area. So by multiply pressure to the area, we can get the force. So, and this force is force for concrete. Okay, and then the force for steel is, this is the stress of FYK. This is the stress, okay, for steel, and this is the area of steel reinforcement, AS. Okay, similar concept. Okay, stress times area, we get the forces. So this one, stress of steel, you can see here in this slide. Okay, this is steel. Fyk divided by Yx, gamma s. This is the partial factors of safety. The value is 1.15. So this, okay, 1 divided by 1.15 is equal to what? Equal to 0.87. Okay, so that's why we get 0.87 here. Okay, here 0.87. Okay, so and we simplify. Okay, let's say this one for the concrete. Okay, this is okay. FST is, this is the stress. Okay, stress. Okay, AS is the area, so we get the forces, and this is, I explained before. And this one, this is the, for concrete, this is the area of concrete for area of concrete for compressions. Okay, we'll undergo compressions, and this is the stress. Okay, the stress here. So we do these calculations, and then we can find that the x is equal to 0.87 FYKAS divided by 0.45 FCKB. Okay, I hope we can try these equations to make a proper calculations. Okay, and this is by taking moment about FCC or FST. Moment of resistance for the sections can be calculated as follow. Okay, moment. Okay, let's say, okay, this one. Moment about FCC. The moment is forces times the distance. Okay, so moment about FCC. This is FCC. So forces, moment about here is the forces here times the distance. Okay, times the z. So 0.87 FYK times S, we times the Z. Z is equal to D minus 0.4X. Okay, this one, Z here. This is the Z, and this is the D. Okay, here this is D. D minus this one is X over 2. Okay, actually X over 2. Okay, so D Z is equal to D minus X, this one, the distance here. Distance here is 0.8. Okay, 0.8x divided by 2, so it becomes 0.4x. Okay, understand? Understood? Okay, and the moment about FST, FCC times Z, this one. Moment about here is FCC times Z. FCC is equal to 0.45 FCK BX times your Z is equal to D minus 0.4X. Like this one. Okay, and the equation will be used to determine the moment of resistance that can be resisted by the section with specified area of reinforcement. So by using this equation, if we know the strength of the concrete, okay, the compression strength of concrete, if we know the width of the beam, if we know the value of X and we know the value of D, so we can know what is the value of our maximum bending moment that can be resisted by the sections of the beam. Okay, this is maximum. Okay, so we can see here that, okay, from this equation, okay, at the top equation, if the area of steel increase, what will happen to the moment capacity? If we increase the area of steel, what will happen?
Kuat.
Dia lagi kuat. No, dia jawapan dia kena lebih spesifik. Betul, jawapan kamu tepat, tapi dia mesti lebih spesifik untuk dapatkan markah lebih lah. Okay, because AS, okay, we will, if the larger AS will increase the M, betul tak? because this is proportionally. Okay, as increase, so the capacity of moment is increased. So it will be go stronger. But you must you kena sentuh, you kena sebut moment tu naik. So this one lah, higher reinforcement will contribute to higher capacity to resist larger bending moment. Okay, so larger bending moment means higher loading. Okay, so beam yang perlu design untuk higher bending moment perlukan lebih banyak besi. Okay, so dia lebih mahal, cost akan naik. Okay, and then to avoid over reinforced sections, EC2 has limit X to be not more than 0.45D. So we substitute inside the calculations. We substitute the calculations. Let's say the calculation of this one. Yang atas ni. This one. This calculation, we substitute. Jadikan dia sebagai 0.45D. Okay, I hope you can try. You can try by yourself. Okay, let's say this one. Okay, M is equal to 0.45 FCK. I hope you can try by this one later, so you can have more understanding. FCK BX times D minus 0.4X. 0.45 FCK BX, we substitute X as 0.45D, and then D minus 0.45D. Okay, and then we can get this one. Okay, you do your own calculation, try your own calculation, and then you get this one, where the 0.167 is not as K balance. Okay, so we have to check either the value of K balance is less than 0.167 or greater than 0.167. If the value is lesser than 0.167, only tension reinforcement is required, which is singly reinforced. If the value of K balance is larger than 0.167, so we need both tension and compression reinforcement, which is doubly reinforced. Okay, and then this is the calculation of how to determine the level arm. Okay, the Z, how to derive this one. You try by yourself. And then the area of reinforcement for singly reinforced, we know the bending moment, we know the steel strength, and we know the Z from this equation. So we can know what is how many reinforcement are required to be provided. Okay, and this one is for doubly reinforced rectangular sections. Okay, for this one, I think I will talk about this one in our next class, which is on Wednesday. Okay, for this one. Okay, however, I would like to, okay, you have to go through this one. Okay, the design flow chart for bending. Okay, you must check the K balance, either it's lesser or greater than 0.167 to determine either it is the singly or doubly reinforced. And then you just follow this calculation. You calculate the level arm by using this equation. You must practice. Okay, actually, in order to understand well and to let's say to ease you to answer the exam, practice make perfect. You must practice it over and over again. That's why in your project, work-based project, you are required to do manual calculations instead of software. You must do the manual calculations so you can have feel what will happen to Z if the D increase, and what will happen to S if the D increase. What will happen to this one? What will happen to the number of steel? What will happen to the size of steel? So you must try by yourself. Okay, zaman saya belajar dulu, saya buat rumah banglo tu design seorang-seorang, saya buat banyak beam. Okay, you are required to do satu orang cuma perlu buat satu beam, satu column dan satu slab. Zaman saya tu saya buat banyak. Okay, and then you have to check, okay, the minimum and maximum reinforcement according to this requirement by the Eurocode. Okay, and then you must check the minimum spacing and then maximum spacing between reinforcement. This one is okay. We can go through later in the example or the tutorial. Okay, and then this is the doubly reinforced. First, you must check, okay, this one, okay, this criteria, okay, and then you must calculate the area of compression reinforcement required AS prime, and then you got the AS prime, then you can get the AS, and then you check as usual, check the minimum and maximum, check the spacing minimum and maximum. Okay, and then this is the requirement by Eurocode. You must able lah, you must know, kalau you pergi LI, you tolong jangan cakap pensyarah saya cakap macam tu. Tolong jangan cakap macam tu. This is a very wrong. Okay, salah. Kalau you kata kenapa kamu buat this one, okay, minimum reinforcement, value of minimum reinforcement, and okay, this one longitudinal reinforcement. Tadi saya cakap flexural kan, flexural ataupun main ataupun longitudinal reinforcement. This is biasalah, okay, this is nama yang sama, nama yang berlainan tapi dia benda yang sama. Okay, so kenapa ada limit dia 0.0013 BTD. Kenapa limit dia macam tu? You jangan cakap pensyarah saya cakap macam tu. You cakap, you buka Eurocode page 152, you buka and then you buka clause ni. Ini syarat-syarat dalam Eurocode. Okay, kita kena pastikan reinforcement kita over this one. Kalau reinforcement kita based on calculation adalah lower, so kita kena tambah reinforcement kita supaya dia adalah dalam range this one up to 0.04 area of concrete. Okay, this one. Okay, 0.04 means 4% lah, 4% of concrete. Okay, this is the syarat-syarat dia. Kena AS kita kena tengah-tengah kat sini. Kalau lebih, apa jadi? Kalau lebih, kita kena change our punya size of section. Kalau kurang, kita kena tambah reinforcement kita. Okay, and then this is the table tadi, spacing of bar, and then table of reinforcement, tolong cari. Okay, you dah ada table ni kan, you dah download nota ni. Okay, macam mana cara nak gunakan? Okay, let's say kita perlukan 3. This is the number of bar, and then this bar size. This is the area. Okay, area dalam unit mm2 lah. Reinforcement area dalam unit mm square. So let's say kita nak guna bar size 16, 2y16, so the area is 402 mm square. So kita punya reinforcement jadi macam ni. This one, okay, our steel, kita 2y16, this is 2. Okay, let's say 2h16 and the area is 402 mm square. Okay, boleh saya tahu tak kalau area kita if we have 4h20, what is the area of steel reinforcement? 4h20. Sorry, 4h20.
1257.
Okay, good. 1257. This is the area. Okay. If we have 6y35, 6h25.
2945.
Okay, good. 2945. Okay. Okay, what is the combinations? Okay, what is the combinations in order to get 1473 mm square? 1473 mm square. What is the combination of a size and number?
3h25.
Okay, good. 3h25. Okay, this one. Okay. Okay, another one. What is the combinations in order to get apa lagi pilih ya? Debar ni. 1005 mm square. What is the combinations?
5h16.
Okay, good. 5h16. Okay, yang lain boleh faham tak?
Faham boleh.
Okay, one. Okay, two last questions. Dah petang pun seronok Okay. Okay, if the area of steel the area of steel required, okay, based on our calculations, area of steel required is equal to, let's say, okay, let's say 759 mm square. Okay, what is the area of steel shall we provide, and what is the combination? Based on calculation, this is the required. And so what is the area of steel to be provided?
7H.
Sorry, 7H
16.
7H16. This one. Okay, siapa? Aiman dia. Aiman.
Yang boleh tak? Tapi belum 12 kan? 792.
792 boleh. Okay, this one. Okay, this one boleh. This one also boleh. Okay, this one. Okay, segitiga. Okay, any other? Any other option? Siti Fatimah Muhammad Noor ada? Fatimah Muhammad Noor ada?
Tak ada.
Tak ada idea.
Tak ada.
This one, okay, 759. So this one 804 boleh pakai kan? Dia lebih besar. As provided, let's say this one 804 mm2 bigger than as provided. So it's okay. But you have to check lah, check the minimum and check the maximum, and then you have to check the spacing tadi. Okay. So this one adalah daripada mana? Daripada 4Y 4H16. So kita perlukan 4. 1, 2. Okay, let's say 1, 2, 3, 4 kat sini. Okay, kalau Aiman kata tadi 7H12, tak salah, betul juga. This one sini 7. So kita susun dah 7, maybe 2, 3, 4, 5. Mungkin tak cukup, mungkin 6, 7. Macam itulah. Okay, you kena arrange. Okay, maybe kat dari sini mungkin 702 ni, this one maybe 7H12 mungkin lebih jimat dari segi berat besi daripada 6H daripada 4H16, tapi dari segi kerja ini lagi banyak kerja daripada yang ini, sebab banyak besi yang you nak kena potong, banyak besi yang you nak kena ikat dan set up. Okay, so you as an engineer, you plan properly. Okay, tapi kalau yang ini, yang 7H16 ni, this is over design. Okay. So kita janganlah provide lebih-lebih sangat. Okay, sebab kita tak nak over reinforce. Boleh Okay, example nanti kita pergi kemudian this one. Okay, you dah download. Kalau you nak cuba buat, you boleh buat. Hari Rabu kita akan bincangkan this one. Okay, high yield of steel ni 500 lah this one. This one 500 kita gunakan 500 Newton per millimeter square. Samalah, problem tu pun sama juga. Okay. Okay, any question? Modul dah beli ke belum? Okay, kalau tak ada question, saya stop recording. Okay, thank you so much for your attention. See you on next class.